Okay, we're in section 14 and we're going to do the examples. As you go through the examples, they're being done by hand. I may show alternative techniques of doing those examples, but the bottom line, I'll try to follow what we've done in class with few exceptions. All right. If the exceptions come up, they'll be to introduce a possible different way, a way that you know how to do these things from the past. All right. So we'll do 1, 2, 3, 4, 5, 6. Now 6 asked me to graph it. So what I do is I'll, at the end of it, after knowing everything, I'll go back and I'll show you in Sage or Grapher how to graph that. All right. Number 7. And I guess number 8 also has to graph it. There's another one that asks us about an error over here. So I'm going to make sure you know that we're going to also, for number 5, we're going to go back after I finish the entire assignment by hand. We'll go back and show you to do that on a computer. All right. So I'm going to switch to the whiteboard now. And as I do that, you should also get ready, use paper and pencil and try to follow along. So give me 1 second. And let's talk about problem number 1. So number 1 says calculate the Taylor polynomial T2, T3 centered at x equals pi over 2. Well, the first thing I do is I got to generate derivatives. All right. So I'm going to write f of x down. 1 second to do so. And that's 9 sine x. Now, if the derivatives are tough to take, this is a nightmare, but this relatively simple. It's going to be 9 cosine x, f double prime is going to be minus 9 sine x, f triple prime is going to be minus 9 cosine x. And you could do this all day long. Of course, we have to stop at some point, but there is a nice pattern to it. And I certainly arrive back to the beginning at this point, right? So this would be an infinite loop going just through the cycle again and again and again. Now, what do we have to do? We have to evaluate this thing at pi over 2. So f of pi over 2, f prime pi over 2, f double prime pi over 2. And hopefully they're going to pick very simple numbers for us to evaluate. Okay, so f of pi over 2 is going to be 9. F prime of pi over 2 is going to be 0. F double prime pi over 2 is minus 9. F triple prime evaluated pi over 2 is 0. And then the fourth derivative value of pi over 2 is going to be 9. All right. Then we're going to write our Taylor polynomial down. And I'll get back to the question over there. The Taylor polynomial, I'll just put down t of x. We'll start it off. And I'll tell you what this looks like. This looks like f of x. Well, you know what I should do here? I think they didn't ask for a Taylor polynomial. I got to go back over here. They asked for T2, T3. Let me put that down for you. My eraser out. I don't want to go too far on this one. T2, and it's going to be centered at pi over 2. So let's write this down. So it's going to be f of pi over 2 plus f prime pi over 2 times x minus pi over 2 to the first power. Whoops, sorry about that. Plus f double prime pi over 2 times x minus pi over 2 squared over 2 factorial. Let me put that down for you. Certainly you said, I can't remember what these things are. That's why we write things down. We write them down so you can look at them. And what's f pi over 2? It's 9. What's f prime pi over 2? 0. What's f double prime pi over 2? Minus 9. I'll clean this up in a second. 2 factorial is 2, and x minus pi over 2 squared. So I'm going to write that down. What do you get? 9 minus 9 over 2 x minus pi over 2 squared. They also asked for T3. And to get T3, all I have to do is add one more term onto this one over here. So I've done the initial work. Let's write this down. Minus 9 over 2 x minus pi over 2 squared plus the next term. What's the next term going to be? F triple prime pi over 2 times x minus pi over 2 cubed over 3 factorial. But what's nice about this, and again, if you can't remember, that's why I write things down, that's going to be 0. So T2 and T3 are the same thing. Let's write down T3, nice and neat. It's going to be 9 minus 9 halves x minus pi over 2 squared. All right, so T2 and T3 are the same thing. Again, I know you're going to hear me say this over and over again to you. Mistakes happen, and that's why we give you a key, and we want you to look at the key. So the key over here, I'm looking at it, it's 9 minus 9 halves times x minus pi over 2 squared, and both of them are the same. Again, make sure you understand that these answers are given over here for you. All right, let's go to the next one. And this one's a polynomial, and they want me to do T2, T3 at x equals 5. All right, let's write this down. So I'm going to write f of x down. It's number 2 now. And that's going to be what? X4 minus 2x. Now, polynomials are really easy to differentiate. Whoops, I don't go too fast there. Let me get my eraser out. That's going to be 4x cubed minus 2, second derivative. And again, really easy to write down. Let's see if I did that right, though. That's 4x cubed. Yeah, minus 2. So you get 12x squared. Let me put down the third derivative now. 24x. Let me put the fourth derivative down. 24. And I hope you realize here on out, the derivatives are really to take, they're all going to be 0. All right. Now, what do we have to do? Evaluate this at the center. And what's the center? The center is at 5. So let's write this down. So f of 5. Let's see. You get 125, 625 minus 10, 615. I'm not beyond making a mistake, by the way. So this is what I'm going to say again. Please look at the key to make sure you're doing okay. Then you get 125 times 4. That's 475. No, I'm sorry. I made a mistake there. 4 times 125 is 500. So 498. And let's do f double prime at 5. We're getting easier. That's 25 times 12. 250, 300. F triple prime, 5, 24 times 5 is 120. And if I did, F4 at 5, well, that's pretty simple. That's 24. And then there on out, they're all going to be 0. All right, I'll put that down for you, though. Now, someone says, I didn't think they asked for that. Well, I don't even know what they asked for at this point, but I know I have to do that. All right, what they asked for, calculate the Taylor polynomial T2, T3 at x equals 5. Let's write this down. And I want to keep my eyes on this over here. So I'll write T2 down. It's going to be f of 5, which is 615, plus f prime of 5, which is 498, times x minus 5 to the first power, plus, what's next going to be 300 over 2 factorial x minus 5 squared. If you simplify that, you get 615. I'm not going to multiply that, though, by the way. Whoops, I spoke and I wrote something wrong. Plus 498, x minus 5, plus 150, x minus 5 squared. That's T2. They also asked for T3. T3 should be easy to write down. And I'll tell you why. It's this thing here. Plus the next term on. What's next term on going to be? I got to look at it. It's going to be 120 over, and I have to do the arithmetic on the side. X minus 5, or the third power now, right? And that's going to be 3 factorial, which is 6. So 20 x minus 5 cubed. Again, mistakes happen, and it's why we want to give you a key. And if I do that, I'll look at the key and see if I got it right. 615, 498, x minus 5, 150. I got this one. Did I get the next one right? Let's see. Yep, I got that one right too. Now, certainly they say something kind of convenient over here. They say if you can continue and get, T4. Well, let me write that down for you. T4 should be easy to write down. Well, let's go to the fourth one. What's the fourth derivative? It's 24. X minus 5 to the fourth power over 4 factorial. And what's 4 factorial? It's 24. So that's pretty simple. I'm going to get my eraser out. 4 times 3 is 12, times 2 is 24. So it's just going to be this over here. All right, and if you want on further than that, and by the way, I want to point out we're matching that one too, even though they didn't ask for that, we're matching it. That's right over here. They say though, if you expand it, you're going to get this back over here. Now, what are you getting back? No kidding. We're getting this thing back. We should be getting it back. It'd be a perfect fit. All right. So let's go to the next page. And by the way, I didn't multiply this out. You may want to multiply it out. It's a lot of work though, but stuff you learn in math 120, but I don't think you could certainly multiply that if you wanted to. All right. Number 3, I'm going to show you a little different way of doing it, but we're still going to do what they're asking us to do. And over here, what I'm going to claim over here is that this sort of looks like a geometric to me. And a geometric, you probably should know this thing over here. And this is geometric. This would equal 1 plus u. You learned this in math 120, plus u squared, plus u cubed, plus yada, yada, yada. And it's convergent. You learned this in math 120 when the absolute value of the u was a proper fraction. All right. So I'm going to write that down. And again, I'm not saying that's why they asked me to do it, but this is going to be 3. And then it's going to be 1 plus 3x. Well, I got troubles immediately. And the first trouble is I got 3 on top, but I want a 1. And the bottom should be written as a difference. So it's going to be 1 minus a minus 3x. Well, let me write this down. It's going to be 3. And now I'm looking at that geometric thing. What's it going to be? 1 plus u. Well, what's u now? It's minus 3x. And what's next term going to be? Plus minus 3x squared plus minus 3x cubed plus yada, yada, yada. All right. I'm going to simplify it. And again, this is not what they asked me to do, by the way, but it's something you could probably do and get the same answer, hopefully, right? So you get 3 minus 9x plus, well, that would be 27x squared minus, what do you get there? 81, right? X cubed. And this goes on forever. All right. And what is this over here? This is actually T3. Third degree. Let me erase the dots there. All right, let's look at the K. And do they have that? 3 minus 9x plus 27x squared. Yeah, got that. Now, another way to do this one over here, and I'm going to point this out to you, it's not a bad way of doing it, is by long division. And let me show you that. This is 1 plus 3x. Divide into 3. What times 1 gives you 3? 3. You get 3 plus 9x. You subtract, you get minus 9x. So that's going to be minus 9x. You get minus 9x minus 27x squared. Subtract 27x squared. Then what do you get? Plus 27x squared. That would give you 27x squared plus 81x cubed. Subtract. And you get minus 81x cubed. And this could be done forever. What are you getting? You're getting the same thing back. 3 minus 9x plus 27x squared minus 81x cubed. All right. They didn't ask me to do that though. What they asked me to do was this by what we gave you in class. So I'm going to write this over here. F of x is equal to 3, 1 plus 3x to the minus 1. We'll get the same answer, by the way. What's f prime? Well, it's going to be minus 3, 1 plus 3x minus 2 times 3. What's double prime? Well, it's going to be 3 times 2, 1 plus 3x to the minus 3, 3 squared. Let's keep going. And when you get over there, well, you would get minus 3 times 2, 1 plus 3x to the minus 4, 3 to the third power now. And this is going to be centered. Again, if you can't remember, go back and read it. It's centered at 0. All right, so centered at 0. And let's evaluate the derivatives and the function too. What's f of 0? It's 3. What's f prime of 0? Minus 9. F double prime is 0. Let's see, that would be 54, right? F triple prime at 0. Let's see, what's that going to give me? Boy, that's going to be a tough one, right? 27, 81, 243. Let me make sure I said that right. 81, 243, 286, 486. That's a nightmare. It's minus though. All right, so what do we do? Let's write down. So what do we write down? We're writing down T3, right? So it's going to be 3 minus 9. And then it's going to be x, right? Let me do 54. X, whoops, not x minus, I'm not going to put x minus 0 down. I'm going to put down x squared. Let me get rid of that parentheses there. Over 2. And what's the next one going to be? Let's see, minus 486. That's going to be, let's see, 3 factorial now, which is 6. And then you get x cubed over here. And, you know, certainly I got to simplify this. This is 3 minus 9x plus 27 x squared. And 6 into 286 is going to be 243 divided by 3. And I got to divide 3 into 243, right? Well, that's 81. Okay. 3 ways we did it. Every single answer leads to the same, I'm sorry, every single technique leads to the same answer. Every single technique. All right. So let's look at the key, make sure we got that, what they said they were going to get, which is 3 minus 9x. Things are looking good. All right. So one is we went back to math 120. This is math 120. That's really going back to math 100, but I'll be honest with you, for a lot of students, long division is more difficult. So we also did long division. And we're also learning what we're doing in calculus, which is fitting successive derivatives. All right, and that's what we're doing. All right, so we did okay. Now let me look at number 4. Number 4, I'll write it down the side for you. That's f of x equals e to the 2x. I'm going to start writing down derivatives now. And again, the hope is they're going to be easy to write down. What do you get here? 2 e to the 2x, f double prime x, 2 squared e to the 2x, f triple prime. That's going to be 2 cubed e to the 2x. The fourth derivative, 2 to the 4th. I think you get the idea. You could write down the answer pretty easily over here. What do they want me to do? T4. I'm good to go. Centered at ln 8. Wow, centered at ln 8. All right, let's write down. F of ln 8, 64. F prime ln 8, 128. F double prime, by the way, you learned about logs in math 119. F triple prime ln 8 is 256. F triple prime ln 8 is 512. F4 ln 8 is 1024. Let's write it down now. I'll put this over here. And I guess we're doing, I got to remind myself, I think it's T4. I don't want to do something I'm not asked to do. T4 centered at 8, ln 8. Let's write it down. 64 plus 128 x minus ln 8 plus 256 over 2 factorial x, oh boy, that doesn't look good, x minus ln 8 squared plus, let's see, 512 over 3 factorial, which is 6, x minus ln 8 cubed plus 1024 over 24 is 4 factorial, x minus ln 8 to the 4th power. Now, by the way, I don't mind the answer, but I am going to simplify it, all right? And then we'll look at our k. Let's see, 128. Again, I'm just doing term by term now. That's all I'm doing. And that's going to give me what? Plus, let's see, 256 thirds, right? Boy, that's going to be a tough one. Let's see, 512 over 12, 256 over 6, 128 over 3. Wow, that's weird. Whoops, didn't know I put that down. All right, let's look at our king. And yeah, I know it's a lot of work, by the way. I'm gonna have to pull that in the side. And again, really what we're trying to teach over here is that this is what you need to be doing. It's not like I need to do this, it's you need to do this, right? You need to look at the K. And why is that? You're preparing for exams. I'm not preparing for an exam. So let's take a look at it, see how we did. 64, 128 ln x minus 8, 128 x minus ln 8 squared, 256 over 3 x minus ln 8 cubed. Wow, 128 thirds. Excellent. Okay, let's go back. And again, I know it's a lot of work. All right. This one says they want the error to compute. Again, as I said, I would come back later on and show you this using a computer algebra system. But let's see, calculate telepolynomial T2. Well, this should be very easy. And what I mean by that, f of x, I'm sorry about that. F of x couldn't get any easier. It's e to the x. And every single derivative, no matter what derivative I take, is going to be the same. No matter what one I take, it's going to be the same. So this is going to be really easy to write down. And if it's centered at 0, every single one evaluates to 1. So this should be really easy to write down T2. So what's f of 0, 1? Plus 1 times x, plus, well, let's see, that's going to be 1 divided by 2 factorial, 1/2 x squared. That's T2. All right, now here comes a problem. What they want me to do is they want me to evaluate something. So what they want me to do, look at this over here. This is f of x. What's f of x? E to the x. What they want me to do is find out what the difference is between those guys. And what I mean by that, at a certain value. Now this value over here, it's close to 0, but it's not that close to 0. So really what you're going to do is you're going to do e to the minus 0.4. Yes, I'm going to use a calculator to do that. Minus, I'll put this in parentheses over here and I'll go back. I'll do that on a computer later. It would be 1 minus 0.4 plus, well, it'll be 2, right? And then 0.4 squared. All right, my claim, if you do that, you get this number. But I'm going to go back later and do this using Sage. Later. All right. So if this is an exam question, what should you write down? Basically the work. You can't do the computation, but write down what the computation is, all right? Let's go to the next page. This one's also going to require the use of a computer algebra system. Again, I'll come back later and I'll graph it. But right now, what I'm looking at, I just want to, get the Taylor polynomial. And they say f of x equals sine of x. And again, it's good to read these things. They want T5 centered at pi. All right, let's write certain derivatives down. And they want T5, by the way. Cosine x. And again, this is a really easy derivative too. It would be awful to give you problems that weren't easy to differentiate. And what do you get over there? I guess you get cosine, right? Minus cosine, I mean. And the fourth derivative is going to be sine x, right? Well, we're back at the beginning now. And this is going to keep repeating itself. And what's that going to be? Sine x. I'm sorry, cosine x. All right, let's write this down. I'll do that in a second. I'm just writing the things down. Centered at pi. Well, pi is going to be 0. This will be -1. This will be 0. This will be 1. This will be 0. And that'll be -1. Well, isn't that convenient? Let's write this down now. T5. We'll check it with the key later. Well, I'm going to write it down. I'll clean up later. 0 minus 1 times x minus pi to the first power plus 0 times x minus pi squared over 2 factorial plus 1 times x minus pi, let's see, that would be cubed, right? Over 3 factorial, which is 6, plus 0 x minus pi to the 4th power over 4 factorial. And then you get minus 1 x minus pi to the 5th over 5 factorial. Well, I got to do that. And I know it's tough, but we have to write down T5, and then we'll check it with the key. That's going to be minus x minus pi. And then you're going to get 1/6 x minus pi to the 3rd minus 1. I'm not going to put that down. Let's put down x minus pi to the 5th power. And 5 factorial, 5 times 4 is 20. 20 times 3 is 60, 120. All right, that's T5. And again, I'd like to check it. This is why you want to check these things. I want to see if I got it right. So I'm looking at it, and they didn't simplify it, but they did this over here. So I'm going to do this thing. I'm going to do this in Grapher. Again, I'm not saying one application over another is better. All I'm saying is the more tools you have at your disposal, the better it is for you. All right. Let's do number 7. And number 7 is a Taylor polynomial, but it's a degree 15. And I got to be honest with you, degree 15 might be tough to do. But I'm going to say, f of x equals 1 over 1 minus x. This is clearly that geometric problem. So it's 1 plus x squared plus x cubed plus yada, 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 yada. That's good. So if you were to write down T15, what would you get? 1 plus x squared plus x cubed, yada, 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 up to x15. All right, that's not so bad. All right, now what other way could we do it? We could go back to math 120 and recognize it's geometric. We could also do it by long division, and let's put that down for you. I think you can see this goes very quickly, by the way. And you get a yada, yada, yada. You get the same thing over and over again. But I got to really say that we need to go back to what they're asking us to do. And someone says, what were they asking us to do? What we did in class, derivatives. So now I don't want to bore you with the detail, but I hope you can look at this thing over here and realize these are fairly easy derivatives to write down as long as you don't simplify them. Right? As long as you don't simplify. All right. Now, someone says you write the sixth derivative down, I start to realize there's a pattern to it. And if I look at the pattern to it, what it's going to be, well, every derivative, it's, like the first derivative 1 factorial, second derivative 2 factorial, third derivative 3 factorial, fourth derivative 4 factorial, fifth derivative 5 factorial. That's why I'm writing these factorials down. And then how would you write this down? So if you were to write the polynomial down, t, these are centered at 0. Well, all the derivatives just simply evaluate to the factorial. So for example, the fifth derivative is just 15 factorial. So this looks really easy to write down. So what are you going to get? 1 plus 1 times x plus 2 factorial over 2 factorial x squared plus 3 factorial over 3 factorial x cubed plus yada, yada, yada. I think you get the idea. 15 factorial over 15 factorial, x to the 15. All right. So I know that T15, and T15 is this business over here. And no matter how I do it. All right, let's go to the next page. And the next page is, they give me T15 over here. What they asked me to do, though, is also to look at the graph of it. Now, you should know from Math 120 that this is only valid when the absolute value of x is a proper fraction. And what does that mean? It's only going to work between 1 and -1. When we look at the graph, I'm going to illustrate that the graph of 1 over 1 minus x, which is this graph right here. I'm sorry, just doing that real quick. And this over, whoops, sorry about that. That's that graph over there. That's easy to graph, by the way. It's that polynomial that's tough. And that's this thing over here. And this is only going to fit between -1 and 1. Now, someone says it really doesn't fit it completely between -1 and 1. We'd have to take more terms to get a better fit. All right. So what I'm going to do now is I'm going to go back to using Sage. And I want to talk about how to graph these guys and how to do what they've been asking me to do. So let me do that. I'm going to stop this share. We're done with the homework, not examples on the homework. So let me stop this share. And I'll do a new share. And I'm going to do the calculations for you. So I'm going to launch Sage. Just give me a second to do so. And I'm pretty sure I said I was going to do number 5. I'm just going to, there'll be a little retentive here and reset. X is a variable. So X equals a variable. I'm going to say a function f of X is going to be e to the X. And I'm going to say T of X is going to be equal to 1 plus X squared divided by 2. These are things that we did at the whiteboard before. Now, what do they want me to do? They want me to compute something. Now, I want to point this out to you. This is going to be a little frustrating for students, but you're going to have to learn how to type things in. And sometimes you're going to be disappointed when you type something in, you're not getting back what you expected to get back. So let's put this down. What do we want? We want to do f of X at minus 0.4, and we want to subtract away T, evaluated at minus 0.4. And that ABS stands for absolute value. And what does it return back to me? That number that we're getting over here. Now, granted, they get more digits over here, but let's see if we got it. We got 0096. Yeah, they did a proper rounding. The 7 should be rounded to an 8. So that's done. So we said we're going to go back and do that. And you should learn how to use software. Now, I don't mean you have to learn how to use Sage. but you should learn how to use software. Now, this one over here, I said I was going to do in Grapher. And let me do that for you. I'm going to open my application Grapher. That does not mean you're using Grapher. You use the software you're comfortable with, including if you want to use Sage. All right. So I'm going to graph this out for you. And someone says, how do you type that in? Well, I'm going to graph in sine. Whoops, y equals sine. Sorry. I'm really screwing up here, aren't I? Whoops, that's not good. That's sine. And now I want to graph the other guy. I'm going to make a new equation. Let me just pull this up a little bit. And again, I'm not saying you need to use any particular software. And that's going to be one of your misfortunes when you go to a place like NJIT, they say, oh, you have to use this. And I think to myself, you should use what you like to use, all right? So let me type the next thing in, plus 1 divided by 3 factorial. I'm actually going to type in the factorial symbol. And then x minus pi. That's going to be cubed. And then it's going to be minus 1 divided by 5 factorial. That's going to be x minus pi to the 5th power. You're going to make mistakes when you do this. Now, what I mean the mistakes is typing mistakes. So this is why we give you graphs. But before I show you my graph that I got over there, I'm going to pull this around. And this should be, a good fit around the number pi. So let me pull it, and pi is about 3.14. Now, what are we saying? We're saying that this is about pi. The fit should be really good about pi. But you notice when you go to the left and right, the fit gets bad. All right. Let me, I'm going to just change the format of this a little tiny bit. I don't like looking at a grid, by the way. Whoops, sorry about that. And so what I'm going to do is I'm going to do the accent grid, get rid of the grid. All right. If you want to change the color of these curves, you can. And that's typical. And you can do that in Sage as well. I'll make this one green, for example, so I can differentiate the two. All right. So that's done. And, if I want the other one, I want to make it red or something. And again, if you want to change the scale of this over here, you can. Let me show what I mean by that. All right, I think you're getting an impression here. That's a sine function. That's that Taylor polynomial T5 that approximates the sine function around pi. And again, pi is over here somewhere. You notice the curve, you can't tell the difference. And again, it's not a bad fit, but unfortunately, it's not a good fit over here or over here. All right. Again, I put a graph over here for you as well. All right. So let's put the next one down. This was number 7. This, for a lot of students, it says, oh, I can't type that. It's too many things to type in. It's 16 terms. Well, this is why you want to start to learn how to use software. So let me go back to my Grapher application, and I'm going to graph in, one thing at a time. I want to graph in, 1 over 1 divided by 1 minus x. All right, that's graphed in. And now I'm going to graph in, y equals, and this is going to seem strange to you. And what I'm going to graph in is I'm going to graph in a sum. I'm going to go over here. And again, I'm not saying this is software you're using, but I just want to demonstrate what I would do. I would say n equals 0, and I'm going up to 15. Now, where'd you learn about sums? Certainly in the first place you're interested in getting college is mth122. And you learn how to write things with sums. And what's this going to be? X raised to the power n. And what is that going to be? N equals 0, n equals 1, n equals 2, yada, yada, up to 15. And let's look at the picture. And I'm going to recenter it. Give me a second here. I'm going to center the origin, equalize axes. And I'm kind of seeing it, but I want to make sure that what we're doing over here is we need to color these graphs to differentiate the two. So let me get my inspector out. Give me 1 second. I want to pull this around. I want to get a better picture over here. All right. So give me 1 second to do so. And let's make this guy here a different color. Let's make him red. Magenta. All right. And let's make this guy green. All right. I hope you realize that looking at these things over here, the fit between the two curves is really good in a certain region, but not everywhere. So someone says, I wonder what that region is. The region is what was discussed in Math 120 between -1 and 1. I want to put those lines in for you. And those lines would be x equals -1. And the other line would be x equals +1. Whoops, I made a mistake there. So I'm going to zoom in, and give me a second to do so, into that region. All right, what are you noticing over here? Well, the two curves really do agree in a band between -1 and 1. Now, I realize some people are going to say it doesn't fit so good over here. You could take higher values of n. For example, let's say I want to n is 100. Let me edit that for you. Now, someone said if I do 100, would the fit get better? It'll get better. Right, it'll be 111 terms. I'm sorry, 101 terms. Watch this region over here change now. It got better. It got much better. All right. Now, if you want to 1,000 or 10,000, you're really stretching the bounds of reason there, but it's going to get better and better and better. All right. So it fits between -1 and 1. Okay. So that covers it for the examples. So for the most part, I hope you're reading through what we've given you. I hope you're paying attention to what we're talking about, and I hope you're starting to think about how to use technology to improve your learning of the material. All right. Not to do the material as a crutch, but to learn the material. Thank you. Brian, are you there?
Yes.
What can I do for you, Brian?
Understanding this.
Oh, this was different. This is not your material. This is office hours, Brian. This is not class.
Oh,
So do you have a question from the course that you're taking?
kind of.
You let me know, and I'll try to answer your question, okay?
Okay. So